Hi, my name is Ugazi Matthias Joseph, and I'm teaming up with Nursery Catherine. Our project is about reinforced generative adversarial contrastive learning for defective Tyre detection with knowledge distillation. To give you a brief introduction about this project, Tyre defection can come all the way from companies. All tires are being manufactured. We can have tires that have irregular uh, traits, and others can have cracks. So these tires can be a danger to a human life while they're being used in the transportation. Then we also have tear and wear as tires are being used since they're exposed to the poor roads and also things like heat. For example, a tire can be overflated or underflated due to the condition it is. Therefore, to do a tire inspection can be a little bit tiresome and time consuming to humans since you have to check each and every tire at once. But then use of machine learning, for example GANs, it can be easy to detect and also compute these defects of tires, comparing them with the actual images. So in this project, we shall be using machine learning approach inspired by generative adversarial networks, CycleGANs, for detection, and then we shall use computer vision for real-time capturing of images, and then we shall process the data using the GANs, and then be able to train the machine learning model on good tires and the bad tires. Then it can be able to differentiate between good and bad tires just by looking at the images from what we shall have captured using the cameras. Then the system will be capturing images, and then they will be pipelined with minimal inspection while offering greater perception and efficiency. Then we have technical definitions. In this, we can have defect detection, which is a process of identifying tires that are having issues, for example, irregular treads, cracks, and under deflation and over deflation. Then we can have generative adversarial networks, which is a kind of machine learning model that is employed in a competitive framework consisting of generator and discriminator. So in this case, the generator takes a real image and then tries to create a realistic fake image and then feeds it to the discriminator. So the discriminator, when it receives the real data and fake data, is should be able to distinguish between what's real and what's fake. Then we have CycleGAN, which is provides image to image translation framework that enables domain adoption without paired datasets. This will enable us to distinguish between images without comparing them with their immediate neighbors, but within the entire dataset. Then we have computer vision, which is a branch of AI that enables machines to extract meaningful information from digital images and videos. So in computer vision, we shall use cameras to capture time images of the tires. Then we have image processing, which will be a transformation of images into digital data, and then perform operations on them, such as extracting out features like residual treads or cracks on the tires. Then we have knowledge distillation. Knowledge distillation is a machine learning technique that transfers knowledge from a large complex model to a smaller, more efficient. Then current trends or research. Uh, this, like I explained, we can use thermal imaging, X-ray, and vibrating analysis with computer vision models to detect defects in tires. So using multiple model GAN architectures, we can be able to test and generate synthetic tire defects images across different signing modalities, and then we can use the GAN to train the model using real and fake data. Then, in tire detection, shall use reinforcement learning to optimize contrastive learning by dynamically adjusting similarity threshold between good and then we shall also use computer vision. Computer vision enables us to capture real-time images of the tires, those with anomalies, and then they also good tires. Then we shall be able to detect anomalies using GANs, and then CycleGANs. And then we shall also use knowledge distillation, which enable us to distinguish between the images, and then it also helps us to plot graphs for the data. Thank you.
Hi there, my name is Nasali Catherine and I'm going to be taking you through the problem statement. The application domain specific problem will be the problem we are trying to solve, and that would be tire defects altogether from cars that are being used in day-to-day life, and even the tires that have not yet been released. We want to reduce the amount of accidents that we have, because these defects can lead to blowouts, loss of control, and sometimes fatalities. Now, visual inspections are slow, prone to error, and are subjective. So, what would be the problems we would face as we try to make this model using GANs and computer vision? We have complexities in the tire image texture and patterns. As you know, different tires from different companies have different features and different trends. So these complexities might make our model hard to know the differences. We also look at the high resolution images and intricate details. When you take a picture of high resolution and an image of low resolution, a higher resolution is going to take higher, like it's going to need much more processing, and sometimes these intricate details that we have might be mistaken for defects, and yet they are not. So we have overfitting, underfitting, and class imbalances. So overfitting is when a model trains on so much data to a point that it gets biased at a certain point. Like if you keep on showing a model defective tires of a certain type, whenever it sees anything that is close, even if it's not a defect, it's going to say it's a defect. So this makes it hard whenever they present it with new data. Now, underfitting, in this case, our model is going to be trained with data that is scarce. We give it less images. We give it good images and bad images, defected tires, but um, the images are 50, let us say 100 each. This model is not going to be trained well. It's going to generalize. Yes, it will generalize. So when it's presented with a tire with a defect, it might end up putting it in the good class because it hasn't seen a variety. As for the class imbalances, this is when you don't balance out the good and the bad tires. We try to balance the datasets to make sure that the good tires are in balance with the bad. In our proposed solution, we intend to use CycleGANs for domain adaptation to generate synthetic images. As you can see, we don't have paired images. Like we say, we have fake data and real data, and as GANs are working, they work with a generator and a discriminator. So we are going to use CycleGANs to generate synthetic images for defective and both good tires. So we shall use contraceptive learning to improve the feature extraction, the tires, the pixels, and even the textures that we shall have there. We intend to use knowledge distillation to make to make the model more efficient. We also want to use convolutional neural networks and CycleGANs together to learn representations of tire images. Regularization techniques are to be used to mitigate over. So I'm going to give you a brief description of our dataset. We have 1,856 images. As you can see, we have images from the good and from the defective tires. we intend to use them to compute. We shall resize them in order to make computation faster. As you can see, we intend to use GANs, computer vision, and knowledge distillation for real-time tire defect detection. Thank you very much. That's it from us. Have a nice day.